What exactly is a partition function, and what does it tell us? From your reading, you will know that the fraction of particles with a given energy epsilon sub I, or the probability of finding a particle with energy epsilon sub I in my system, is proportional to the degeneracy of that energy times this factor, this exponential factor, e to the minus energy divided by k Boltzmann T. Like all good probability distributions, this probability distribution needs to be normalized. In other words, the sum over all the probabilities needs to equal 1. This follows logically from the fact that the fraction of all particles having any energy has to equal 1, or the whole system. So when I sum my probabilities, I have to multiply by some constant in order to ensure that that sum will equal 1. From this, we can see that 1 over that normalization constant, which we're going to call Q, the partition function, is equal to the sum over all states of the degeneracy times the Boltzmann factor, this exponential factor in the energy. Thus, the fraction of all molecules having energy E sub I, or the probability that I will find a molecule with energy E sub I in my system, is equal to the degeneracy of that level, the Boltzmann factor, divided by the normalization constant, Q, which we call the partition function. And Q is simply the sum over all the Boltzmann factors for every energy state of the system. For any energy state that is significantly populated in the system, this Boltzmann factor is approximately 1. Or at least on the order of 1. For states which are unoccupied, this Boltzmann factor is much smaller than 1, or close to 0. Thus, when I sum over all states, Q is approximately equal to the number of energy states that are populated. It's important to note that the partition function is a function of the temperature. As the temperature increases, more states are populated, more states are accessible to the system. And as the temperature decreases, less states are accessible, and therefore less states are populated in the system.